Right, today we are going to, this is from P3 in your textbook. And then we're just going to run through a quick um, review of graphing. So what you're looking at here, I'm using Desmos.com. It's an online graphing software because it makes things all nice and perfect when we go to graph them. I just thought it would be a nice visual, and you can use this on your homework to graph things. If you have any questions about how to use it, please let me know. So we call this the Cartesian plane. It was developed by René Descartes, and we usually refer to it as the rectangular coordinate system. All right, so the x-axis here is what we call, I have it highlighted, it's this red line here, and it's the horizontal line here is the x-axis. The y-axis here is the blue line, it's vertical, and x and y are perpendicular to each other. That means they make a perfect right angle. So this green spot that I have highlighted right here, another wonderful thing about Desmos is that when you click on a point, it actually gives you the ordered pair. This, we haven't really talked about ordered pair yet, but this is the intersection of the x and y planes, and we call it the origin. It's 0, 0 because basically it's that intersection. Usually this first number here is the x-axis, and the second one is the y value, and since we're on 0 on both x and y, that's why the origin is 0, 0. So the coordinate system is broken into 4 quadrants, okay? We always work in a counterclockwise type of way. So this place over here it has a purple dot in it, this is the first quadrant. This one over here that has this orange dot in it, this is the second quadrant. We use Roman numerals as well to represent these. So this one would look like a capital, kind of like a capital I, if you know anything about the Roman numeral system. Then this has 2 bars with the I. This one down here is the third quadrant with the black dot, and here down here we have the fourth quadrant. Okay, so each one of these dots corresponds to an ordered pair here, and the ordered pair in each, so we sort of write them alphabetically, so it's always x comma y, and what the x-coordinate is first of all, let's talk about the x-coordinate. The x-coordinate is the directed distance from the x-axis. So you see when they're on the right-hand side over here, when I click on these 2 points, my x's are both positive. That's because this one is 1 unit, and when we're talking in terms of positive and negative, right of the origin for the x-axis is considered the positive direction. It's how we distinguish which way we're walking, basically. And so the 1 here means I have 1 unit to the right of the origin. That's where this 1 comes from. And this 2 is 2 units as well from to the right of the origin. Now these 2 points over here both have negative x-coordinates. We're just talking about x for right now. And that is because I'm moving to the left of 0. And so this one is 2 units from 0. It's just the direction is telling us it's to the left. So that's why this one has a -2. This one has a -3. Again, 1, 2, 3 steps, but to the left. That's why it's negative. All right. So let's talk about the y-coordinates here for a second. So y is the y-axis is the vertical blue line here. And when we're dealing with y, above the x-axis is considered the positive direction, and we've defined the bottom when we're going below the x-axis, we have negative y values. So if you look here, right, so these 2 on top, this is the first quadrant, this is the second quadrant, they have, the points are above the x-axis, and so both of these y-coordinates are positive. So here I have +2 because it is 1, 2 steps up above the x-axis. This one is +4 because it is 1, 2, 3, 4 steps above the x-axis. Now these down here, this is the third quadrant again, and this is the fourth quadrant, both have negative y-coordinates because they are below the x-axis. And so this one here is -2 because it is negative, it's 2 away from the x-axis, but it's moving downward. And this one is 1 unit from the x-axis, again, from it's going downward, which is we use the negative sign to tell us the direction. All right. So you may notice that, let's just talk briefly about points in each quadrant. So let's talk about this point in the first quadrant. You notice to get anywhere in this first quadrant here, I would need to move to the right and move up. So that means that both my x and y coordinates will always be positive if I'm going to land in the first quadrant. So let's move into the second quadrant. So this whole space here is the second quadrant. In order to move into this space, I'm going to need to move to the left, which means I'm going to have a negative x value because that's to the left of the y-axis. And to get up here, I'm going to have a positive y value. So points in the second quadrant always have a negative x value and a positive y value. Right? When I move down here into the third quadrant, to get down here, I'm going to need to move to the left as far as my x-coordinate goes, making it negative, and I'm going to move downward also, making the y-coordinate negative. So this one will have both coordinates, which are negative. Then when I get into the fourth quadrant over here, I'm going to need to move to the right for x and then downward for y. So that means my x-coordinate will be positive and my y-coordinate will be negative. Okay. So one thing that I haven't talked about that I can put on here, let's look at this point, 3, 0. This is how we put them in, as I have this little spot over here, and boom, looky there, my point just shows up. My point here is 3, 0. So this particular point is actually on the x-axis, and it has a special name. It is called an x-intercept, and it's called an x-intercept because it is actually on x, right? It's intercepting the x-axis. So something that you might notice, let me put another x-intercept on my graph here. Let me say 4. Okay, so there's another one. Here I have, well, the way that we say them is I have an x-intercept here at x equals 3, and I have an x-intercept here at x equals -4. So something that you might notice here is that to sit on x, right, then that means that I'm not moving my y either up or down. If I move my y up or down, I wouldn't be on x anymore. I would be floating up here in one of the different quadrants. But these actually are sitting on the x-axis. So one special thing about an x-intercept is that the y-coordinate is always 0. So what do you think we need to do to get a point that lands on the y-intercept, or on the y-axis? We would call that a y-intercept. So if we think about this, right, these were x-intercepts, and the x, we had a value for x, but a 0 for y. So if something were going to sit on the y-axis, then I wouldn't be moving it back and forth with my x, I would just have a y-coordinate. So the way that I can put some y-intercepts on here is to write points that have a 0 for my x-coordinate. Let me put 1 negative and 1 positive here. Oops, I forgot my comma. Okay. And so, let me take this away. So I've put 2 new intercepts on here. Here I have the 0, 2. Let me take away these other. It's getting a little cluttered here. And actually, the origin here, I didn't really mention it, but is both an x and a y-intercept at the same time because it is actually on both of them. So you notice that these 2 points, this 0, 2 and this 0, -3, so I didn't move in either direction as far as my x-coordinate goes, but I moved 2 in the positive direction here, making this 0, 2, -3 here, down, so it makes it 0, -3. These are what we call y-intercepts because they are sitting on the y-axis. And so something unique to a y-intercept is that the x-coordinate is always 0, or else it would not be on y. All right. So let's play a little bit of a game here. So now that we've talked about what the different signs in each quadrant are, let's play a game. So we want to play this game. It's called What Quadrant Am I In? And so what if x is less than 0 and y is greater than 0? So that means that my x would be negative and my y would be positive. So which quadrant or quadrants am I in? Let's see. So I'm looking for something where my x-coordinate would be negative or less than 0. My y-coordinate would be greater than 0, meaning it's positive. Well, over here, let's take these. Let's hide our origin. So in the first quadrant, remember, I had both my x and y positive. Now I want my x to be negative and my y positive. So my y is positive. This is good. That's a step in the right direction. But I don't have the right sign on my x-coordinate. Now, since I know that I need my y to be positive, I know I can kind of rule out quickly, I know that both of these are going to have what? Right? They're both going to have a negative y-coordinate. And so I can rule out both the third and fourth quadrant here pretty quickly because my y value I want to be positive. Again, I'm looking for where's my point if my x is less than 0 and my y is greater than 0, meaning I have an x-coordinate that's negative and a y-coordinate that's positive. And so the only thing that I haven't looked at here is coordinate or quadrant number 2, which does in fact give me a negative, right? I'm moving in the negative direction here for x and a positive y, and that's the only one that satisfies this particular one. All right, what if I am looking for the quadrant or quadrants in which my y value is less than -2? So this time, nothing about x. My x can be whatever. I just know that I want my y-coordinate to be less than -2. So less than -2 would mean that my y-coordinate is going to be negative, right? Because a smaller number than -2 would also be negative. So that eliminates for me the first and the second quadrants because my y-coordinate is positive. I'm moving upward in these two. And so both of, actually this one actually is -2. Now these points don't have a y-coordinate that's -2, but you can see that they would if I put my point down here, right? Like if I had -3, -3, it would be down here. My y-coordinate would be less than -2. And if I put a point down here, I could have 2, -3, which also would give me a y-coordinate that's less than -2. So that means that quadrants 3 and 4 both satisfy that particular one. So just one more of those. What if I had the fact that my x times my y would be positive? So what if I wanted a quadrant that would give me, if I multiplied my x and my y coordinates together, I would get a positive number. So first let's talk about how do I get a positive number. Well, I know that if I multiply two positive numbers together, I will get a positive. Then there's one other way which I can get a positive number, and that's if I multiply two negative numbers together. I can also get a positive number. So I'm looking for the coordinate or the quadrant that has both my x and y's where the signs match essentially. So I'm looking for a positive quadrant, and I'm also looking for a negative quadrant. And so what I'm looking for then, right, here I move in a positive direction, x, and to get positive y, I would move up here, right? That's in this quadrant with the purple dot up here, which means I'm in quadrant 1. So quadrant 1 will satisfy my x times y is positive. Remember, coordinates on this are 1 and 2. If I multiply 1 times 2, that is positive, right? Now, in the second quadrant here, I have a negative x, but a positive y. So when I multiply these two guys together, I'm going to get a -8. So that's not what I'm looking for. And so I come down here in the third quadrant, where I got here going negative and also negative y, when I multiply negative 3 times negative 2, I'm going to get positive 6. So numbers or ordered pairs in the third quadrant will also give me a positive x times y. And then my last one here, I just want to check it out to make sure it doesn't work. I have a positive x and a negative y in the fourth quadrant. When I multiply those two numbers together, I will get a negative number. So the solution to my question is in both 1 and 3. All right, so hopefully if you need any more information about graphing, you can look at the P3 section in your text.